Hi everybody, this is going to be our first chapter 6 video going over the 6.1 notes, and we're going to be talking about integer exponents. So let's talk about what an exponent is. Okay, let's say we have 2 to the 4th power. Okay, what that means is we are going to take that base of 2. Okay, so when we have this, we call this our base, we call the little number up here our exponent. And what that means is we're multiplying the number 1 by this base of 2 this many times. Okay, so we're multiplying 1 by 2 4 times. Okay, and if you do that multiplication, you're going to get 16. So we're going to be using this definition of exponents, which is probably a little different than what you've seen in the past. So let's look at some actual exponent rules that we're going to be using. So I want you to pause. I want you to write these down, okay, or they're in your notes, so you don't need to write them down. But know that they're very important and that you're going to need to refer to them often. So the other thing that you need to know is these only work if we are multiplying or dividing things of the same base. Okay, so if we multiply things of the same base, we're going to add the exponents together. If we divide, we're going to subtract. If we have a power raised to a power, so what I mean by that is, if you look at our example over here, we have x to the a power, and then that whole thing is being raised to the b power. We're going to multiply those exponents together. If we have a negative exponent, or if we want to change the sign of an exponent, we're going to think of it as being a fraction, and we're going to move it to really like the opposite side of the fraction. So if we have a negative exponent in the numerator, so think of this as being a fraction here, to make that exponent of n positive, we would have to move it to the denominator. Now, be careful here. We're not flipping the fractions, okay? We're never flipping anything here. We're just moving the base that has a negative exponent to the other side of the fraction bar. And then the last one here is really why we have that special definition of exponents. If we have a base with an exponent of 0, it's actually going to equal 1. So if you think of our previous definition, x to the 0 power would mean we're multiplying 1 by x 0 times, which would leave us with just 1. So anything raised to the 0 power is 1. That's a special rule that you're going to want to remember. So let's look at some actual examples where we're using these rules. So for a, we have two things of the same base being multiplied together. Y to the 10th times y to the, and then if you don't see an exponent, it's always going to be an exponent of 1. So if we're multiplying things of the same base, we're going to keep that same base, but we're going to add the exponents together. Okay, same thing over here. X to the 4th times x to the 2nd power, we're going to keep that same base and add the exponents together. Okay, let's look at division. We have y to the 7th divided by y to the 3rd. We're going to keep that same base of y, okay, and then when we subtract these exponents, it's always going to be the top minus the bottom exponent. So 7 minus 3 is going to give us 4th. For d, remember that this m in the denominator really has an exponent of 1. So when we divide, we keep that same base. 2 minus 1 is 1, so we get m to the 1st power, which we can really just write as m. So let's look at some powers raised to powers. And typically it's going to be written like this, where you have something in parentheses being raised to some other power. So if I have y to the 10th, then squared, I am going to multiply these exponents so that I would get y to the 20th power. Or if I have m to the 3rd and then raised to the 4th, I'm going to multiply these exponents together to get m to the 12th power. Now, negative exponents are where things start getting a little trickier and where people start having a little bit more trouble. So remember, if we have a negative exponent, we need to move it to the opposite side of the fraction bar. And right now, if you look at these examples, we don't have a fraction. But remember that we can always put things over 1. So if I have 2 to the negative 3rd power, I need to move this base and exponent down to the denominator in order for that exponent to become positive. Okay? When I move that down, the mistake that a lot of people make is they think if we move that down, there's really a 0 left in the numerator, but really there's a 1 up here. Because I can always think of it as 1 times 2 to the negative third power. So we're left with a 1 in our numerator. Okay, when I move that base of 2 down, that exponent of negative 3 becomes a positive 3. Negative 3, so notice that this is in parentheses here, is all being raised to the negative 4 power. So again, we can think of this as being a fraction. Okay, we really have a 1 in front here, so when we move this piece down to the denominator, there's still going to be a 1 left in the numerator. So we have 1 over, and then I'm going to keep the negative 3 in parentheses, okay? The sign of the 3 isn't what's changing, it's the sign of the exponent that is becoming positive. So we have positive 4th power now. Now, for each of these examples, we could have actually calculated what is 2 to the 3rd power. What is negative 3 to the 4th power? Okay, that's something you could either do by hand, or if you have a really big exponent and you're trying to figure it out, you could do that calculation in your calculator. So let's look at one last problem where we're kind of combining some of these rules. And these can look really overwhelming, so it's really important to break it down into pieces. So here's my typical process, especially when I have a big fraction like this. I'm going to focus on simplifying the numerator first. Then I'm going to focus on simplifying the denominator. And then my last step is going to be actually dividing these things. So what I mean by, let's focus on the numerator is, let's just look at this piece and see what we can do to simplify this a little bit. Okay, we're trying to condense this, we're trying to clean it up, make it look nicer and easier to work with. So I have x squared times x to the 3rd times y to the 4th. And what I notice is I have two things of the same base that are being multiplied together. Okay, that x squared and x cubed, or x to the 3rd power, are being multiplied. So that means that I can simplify that piece by keeping my same base of x and adding those exponents together. Now, y to the 4th, that's a completely different base. I can't multiply that to simplify with x. I can't add their exponents, so it has to stay separate. So that's the only thing that I can do in my numerator to simplify. Okay, so we've completed step 1. We've simplified our numerator as much as we can. All right, step 2. Now we're looking at the denominator. Well, the first thing I notice is I have this x to the 0 power, which we said is something special. We said anything to the 0 power is really equal to just 1. So in my denominator, if I have 1 times y, I really just have y. And now we've completed step 2. So our third and final step here is dividing. If I look in my numerator and my denominator, I'm looking for things with the same base that can actually divide so that I can subtract their exponents. So in this entire expression, we only have one x, okay? We have x to the 5th power. It's in the numerator. There's no other x's for it to divide with. But with the y's, we have a y to the 4th in the numerator and a y to the 1st in the denominator. So I can divide these y's and subtract their exponents to simplify. So my x to the 5th isn't changing, but when I divide my y's, 4 minus 1 is going to give me y to the 3rd power. Now, this is still over 1 if you want to think of it as still being a fraction, but really, if we just have a 1 in the denominator, we don't need to write it. This is really just going to be x to the 5th times y cubed. And that takes us to our third and final step. We're done. There's nothing else we can do to simplify this. There are no other exponent rules that we can utilize. So this is your complete simplified answer. All right, that is it for this video. Have a wonderful rest of your day.